So I'm going to talk about how we got to the AECB standard and some feedback on the building performance. The scheme's won a number of awards already, shortlisted for some more, and as I say, I hope I can do it justice. So I'm going to give a brief introduction to myself and my company Delta Q, a project overview, talk about design and construction to the AECB standard, look at the energy performance a little bit, and some occupant feedback. So I'll talk about myself first. So I was a geologist for 20 odd years in the construction industry, working on infrastructure projects around the world. And I decided in the 2000s I needed to do something more sustainable, really. And I kind of searched around and I decided I'd get into buildings. And I did a master's at Oxford Brookes in sustainable building. And I started Piers Sadler Consulting, as it was, in 2010. And I didn't really know what I was doing, but I was good with numbers and science and modeling because that was my background. And so I kind of used those transferable skills to develop a knowledge in the construction industry. And I got into passive. I was an AECB member straight away from 2010. I got into Passive House in 2011-12 and qualified in Passive House in 2013. And since then, really, Passive House has been what I've been doing. We work mainly in Passive House, as I've said, but I am an AECB certifier, and I include AECB within Passive House because it's the same kind of knowledge and expertise. We also do whole life carbon, and we've run a couple of projects through the UK Net Zero Carbon Building Standard pilot recently. So we're looking at integrating energy and use, which we've got a lot of experience in, with embodied and upfront carbon as well. We mainly work on large-scale projects, so particularly affordable and social housing for local authorities and housing associations, and we work on schools and university buildings. And our most recent sort of large-scale project is right in the middle. I'll point to it here. It's that one, which is a STEM laboratory building at Warwick University. It's a £160 million project, which is being certified to Passive House. So it's a very complicated and really sort of pushing the boundaries of doing Passive House work. We also work on selected individual houses, so we usually have one or two going at any one time, and we do retrofits as well. And we've done some scale retrofit work as well on a school building, which was never built in the end, unfortunately. So looking at the project background, so the client for the project is Bridport Co-Housing, and they partnered with Bournemouth Churches Housing Association to deliver the scheme. And right from the beginning, it was a collaborative effort between the client group and Barefoot Architects, who really kind of pushed this scheme and made it happen. It's now 50% social rent, so rented out by Bournemouth Churches, and 50% shared ownership. Just a little timeline for you. So the origins go back to 2008, when a group of local people in Bridport who couldn't afford housing down there, because it's a very expensive area, got together and said they wanted to do a sustainable co-housing project. And in 2012, Bridport Co-Housing was Community Land Trust was formed to make the project happen. At that point, Hazelmead, which is the name of the site, rather than Bridport, which is the town, hadn't that wasn't part of it yet. So Hazelmead came along some point. I was involved much later than this, so I'm picking up this from other people. 2016 was the initial planning permission for a smaller scheme on the site, which was intended to be Passive House certified. And then at some point after that nobody is quite sure when, but as part of sort of cost-saving measures, the AECB standard was adopted. So say cost-saving relative to Passive House, of course. In 2020, February 2020, the main contractor was appointed, so just before the first COVID lockdown. That was CG Fry, by the way, who've done a bit of Passive House in Exeter. And by the end of 2023, 53 homes were completed and occupied. Okay, so it's a bit corny, but I'm thinking about the scheme being designed for and by the community. So those people who got together were very engaged with that design process, and they wanted the project to be a community project where people did stuff together, basically. Now, I'm only going to do a little bit about this because it's not my specialism, but just to say about the design. So it's on a south-facing slope, just on the edge of Bridport. There's 39 houses in 7 terraces. There's 2 apartment blocks. They're all 1-bedroom flats in the apartments. and the one on the bottom left has 2 guest rooms and a bike store / laundry. So the guest rooms being kind of part of the idea that the houses are small, not everybody has to have a spare room because there's some spare capacity on the site for other people. And then there was also intended to be a common house, which wasn't part of the current scheme that I was involved in, but it's being built now on site by the residents, and it's not to be AECB certified, just because they're kind of just managing to get it built really, and don't have any spare money. So a key feature of the scheme is the car-free streets with parking on the periphery. So this just means that children can be out and play in the streets. But also the front gardeners don't have any boundaries, so people sitting outside their houses are sitting with their neighbours, so it encourages everybody to know each other, and the feeling is that they do know each other. There's shared growing areas, there's one at the back, but there's also growing areas in front of each house as well, so encouraging people to get out and do food growing together. The scheme has a microgrid. It's owned and operated and was developed by CPRO, who's a Bristol-based company. This was a kind of pioneering scheme for them. They've done 2 schemes like this, and I think that it's very hard work to design, develop, own and operate a microgrid like this. But they basically own the PVs on the houses, they own the local network, and they own a grid scale battery. And then they trade with the national grid, selling electricity when it's most expensive, buying it when it's cheap, and selling electricity to the residents as well. And that's how they make the money, with the idea that the residents get cut price electricity as a result. So the residents got the first 2 years of their electricity for free, and then they get a 20, which they're still in that free period apparently. So I don't know exactly what the deal is there, and whether it depends, whether there's a cut-off for all the residents or how it works, but then there'll be a 20% reduction thereafter. So this just gives you an idea of how much is generated. So this is kilowatt hours in a month. Don't worry about the numbers. The point is that the area below the graph, which is the generated, roughly equals the area above the graph, which is the amount used. Now, I haven't done any analysis of all this and when it's used and how much is stored or anything else, and it's deeply complicated because of the trading with the grid. And apparently, talking to CPRO, they make most of their money with the trading with the grid. So what's used is less significant. But that just gives you a flavour that in some language this is a net zero project, not operational. It's not what I would say because of the seasonal offsets and things. So you'll see in the winter generates much less than it uses, for instance. So Delta Q, where we were appointed at beginning of stage 4 really by the contractor. So design and build project to help with the technical design and construction. We were appointed as AECB consultant and certifier. And back at this point, there was no separate role for the AECB certifier. So our role was basically to do both, which included PHPP modeling, fabric design support, and advice on heating, ventilation, and domestic hot water, and site support and quality assurance. And of course, this started right at the beginning of COVID, and it was a very difficult project for the contractor because prices were going up, difficult getting people on site, and delays on delivery of materials. Subcontractors were going bust. This kind of stuff was going on, so right through the project. Just a very quick reminder about fabric first principles of the AECB standard. So mostly AECB buildings, and including these ones, they aim to have gap-free insulation, high-quality triple glazed windows, heat recovery ventilation, airtight envelope, and minimized and quantified thermal bridging. So just looking at the design of the houses then, so the houses and the flats are all of rectangular design with minimal articulation of the building outline in plan or section. So great for AECB standard, makes it easy to do. But let's have a look at the thermal envelope. So the original plan was to have a thermal envelope here, but trying to save costs and it was always a big driver to push down the costs on the project. And again, this was before I was involved. there was a move to use truss rafters and have the insulation at ceiling level. And then as a compromise, that was the solution. So to have a roof light shaft, but truss rafters as well. You can see just about there's a ventilation unit in a bulkhead in the bathroom. So that's just for future reference in the talk. And then this feature here that's known as the chimney, and from the architect's point of view is supposed to mimic a chimney as a sort of visual effect, was where the ductwork goes out of the building. So that's outside the thermal envelope. Looking a bit more closely then, so the buildings were all constructed in timber frame, off-site manufactured, with PUR between the studs and PIR insulation 50 mil internally to give us a U value of 0.17. In the ceiling, there's mineral wool between and above the joists to give a U value of 0.14, and in the ground, PIR above ground floor slab to give you a U value of 0.12. So just looking at the off-site manufacturer, it was done by SO Modular in South Wales. And they were, at the time, they were doing a passive house school with us, so it was their kind of beginning of their journey in this area. The internal airtight membrane was installed on site, an external breather membrane installed on site. The windows and doors were installed on site, sorry, not on site, in the factory. And the panels were assembled, taped, joined, and finished on site. And brick and timber finishing was also on site. So we didn't get many good pictures from the factory, unfortunately, but we wanted some just to show what was going on. So on the left, you can just about see there's a 189 timber stud, and on top of it, which is on the internal face, is that 50 mil of PIR, which was getting us the U value we needed. So the strategy was really build this like a 189 stud timber frame, but stick some insulation on the inside. And there's the silver is the factory fitted membrane, the factory fitted airtight membrane. And on the right, so I'm just going to do a little video, which is about 20 seconds of the PUR polyurethane insulation being pumped into a demo panel, just to see how the panel fills up. And of course, from our point of view as a QA process, what we're really interested in is that being gap free, and we wanted them to demonstrate it to us, which they adequately did. There you are, so completely full. So that made the job of our job of confirming the quality of the insulation, at least in the panels, much easier. So we also had the ground floor, so that was we had to check that, make sure that was being done properly. Loft insulation, making sure it was all going to the edges, out to the eaves, and that it was at the required thicknesses. And then on the right, the roof light shaft, that was quite difficult because stuffing insulation into that sort of vertical, not exactly defined void was a bit tricky. Just wanted to talk about this detail here. So, and that piece of insulation. So that insulation is 50 mil of PIR. It's all that stands thermally between the inside and outside of the building. So it had to be done right. That was a key thing. On the outside of it, originally we had lightweight block there, which helped us with the thermal performance of that junction. But for structural reasons, the timber frame had changed it to dense concrete block. So we had what looked like quite a poor performing junction there, although when we modeled it, it was actually quite good because the psi value goes right down to the bottom of the concrete for those with that kind of technical knowledge, which meant that we got a psi value of very close to 0 on that, despite the fact that we've only got the 50 mil. But the key was quality assurance wise, we had to make sure that insulation was installed properly, because if it wasn't, then you had nothing between you and the outside. Just to give you a flavour of the roof light shaft, that's what it looks like while it's being constructed from the inside on the left. Getting access to that was really, really difficult. And speaking to the contractor recently, he said on one of the buildings, they had to build a tower up there and then deconstruct it 10 times during the construction of the building. I don't know why, but it was in the way when it was there. So it was really, really difficult to build, and it was difficult to do the work up the tower as well. So that was from the inside. So for the plastering, the airtightness and the decorating. And then from the other side, so the insulation was applied from the loft. And sometimes, as the picture shows on the right, it wasn't done right because, well, there wasn't really a detailed design of the corner of that insulation. So we had to make sure that the insulation was thick enough and continuous enough at those kind of locations. Here's the air tightness. So there's basically 4 membranes on the site. So the silver one, which we've seen on the inside of the panels, and you can see on the bottom right. So those are only the external walls, those insulated panels. So the party walls were made airtight on site. They're with the blue membrane, air guard, and that blue membrane was used on ceilings and also up inside the roof light shaft. And then you've got the grey membrane, which is a vapor permeable membrane, which wraps around the cassettes. So you can see that in the bottom right, which wraps around the floor cassettes, which I'll show you a bit more of in a minute. And then the black membrane, or multiple different HDPE membranes in the ground floor on top of the insulation, but below screed. Just some of the sort of challenges that came across. So if you look at this picture, just here, you'll see that sole plate of the wall goes across the door threshold. So that's how they constructed it. And when they came along, because it didn't need to be there, and cut it out, the people who were doing that had no sense that this membrane was of any importance. So they just cut right through it. So that was my first site visit, the photograph on the right, where that happened in multiple places. So I wanted, and this is so common with these kind of projects, to be on site before the first panel came in from the timber frame, but I didn't get to, I phoned them and they said, oh yeah, we've done the ground floor. And I was like, oh, thanks. So that's really, really typical of not being told what's going on site when you're a long way away. So this detail was a bit of an airtight challenge. So this is the airtightness linking the external walls with the getting round the floor cassette. So we've got this membrane shown in red. That's the silver membrane. I couldn't really do a silver line because you wouldn't have been able to see it. And that one, the orange one, is the grey one, if you'll pardon the colour complexities. So those 2 membranes poke out above that batten, which I'll just point to because of its significance. So this batten was causing us quite a lot of problems because it was squeezing those 2 membranes out there. That batten was installed in the factory, so that created a bit of sequencing problem. So that's what it looked like when it was done, and you can see the silver membrane, which is the red, and you can see the grey on the left, and you can just about see a bit of grey poking over the silver on the right. And those 2 needed to be taped together like that. So it's quite an unusual bit of taping detail. If they could have taped the silver to the grey before the floor cassette went in, then this wouldn't have happened. But at least in some of the buildings, that isn't what they did, because they didn't have time, because the floor cassette was coming in. We've got to get the floor cassette in. We've got to get the floor cassette in. So on the flats, so these were the last buildings built, with a change of personnel on site. So our contact, the passive house guy, had basically moved on and somebody else had come in, and he was keen and listening, but this was all happening at the same time. So we got these really bad airtight details. And in fact, weren't able to deliver the required airtightness for the flats, apparently. So I say apparently because I wasn't involved at that stage of the project. I'm sorry, I was involved. We weren't told about this. So what CG Fry did for the flats is they brought in air barrier. So air barrier is a product and a system where you pump in a polymer into the rooms and pressurize the rooms, and the polymer goes into all the gaps and it seals them. So you choose your air tightness and then you keep pumping until you achieve it. So you have to protect horizontal surfaces because the polymer lands on them as gunge, and you've got to protect your windows because you don't want to gunk up your windows. But basically, that's how they got to the air tightness. Now, we didn't know about that. They never told us that. They just gave us the air tightness certificates. So we heard about that subsequently. It wouldn't have been my preferred way of doing it, but it probably was appropriate at the time. So the windows were Rational Aura Plus, so that's solid timber windows and with aluminium cladding. As I've said, they were installed in the factory, so they came in the panels. And our job was to QA that the right windows were in the right places with the right glazing. And the excerpt from at the bottom just shows the U values, installed U values that were achieved, which were just over 1. As I said, we had to do a bit of thermal bridge modeling. We were using Therm at the time, and we did 16 junctions, and most of them came out pretty low because, of course, it's a timber frame, so it's quite forgiving. The worst junctions were the ducts to the hot water heat pumps and also the soil and vent pipes. So, and the separating wall kind of next. The ventilation, as I said, was some of the smaller houses had the ventilation units. So they've got a Zender 200 unit, which is the one you can see the grey surface of. In the roof, in the ceiling, but above the bathroom in a bulkhead. And on the right, you can see the intake and exhaust ducts, which are pre-insulated Zender Comfo pipe ducts. So I don't know the thicknesses, but the Zender Comfo pipe, I think, might be 15, 20 mil of polystyrene insulation. And you can see they're very short through the thermal envelope because the blue above is the airtightness layer of the roof. The cold roof. So they're popping through there, and they were made airtight from above, but it's quite difficult to do because not much space. You're working in the roof. It's a giving surface, so quite difficult to do, but nice short ducts. On the other side, the plan, I'll try and point to this because it's quite difficult. So this box here is the manifold where the air comes from here and then goes out to all the terminals around the building. So that is, I can't reach it, but up there you can see it just next to the unit. There's one with the red coming out of it, but the other one, there was no room for it. So the intention was that it would be there, but the reality was there wasn't any space there for it. So it was down in a cupboard, and that's what you can see down in the bottom left. So it was quite a convoluted route. I'm just thinking about time. How long have we got? Okay, that should be all right. So, yeah, so this is the larger house ventilation units, and much more straightforward. There was plenty of room in the cupboard. The distribution or manifold boxes were on top of the unit. The commissioning of the ventilation was tricky. So it was right at the end of the project. The project was late. The people wanted to move in. They were commissioning and people were moving in, and then we were hearing about it. We went and visited. We heard some of the systems which seemed to be louder than they should. We got into conversation with the subcontractor, who then went bust. The second subcontractor was appointed. They engaged with the designers. They engaged with us. They said, yeah, we can sort it. They made a few tweaks and started commissioning, and people were moving in kind of the next day. And we got a load of certificates saying it's all good. So that was what we had to accept. I'll revisit that in a minute. So heating domestic hot water, we were part of our early role was just to test different scenarios, and one was direct electric for both. One was direct electric heating with domestic hot water heat pumps, and one was an air source heat pump for both. And the push was for this solution, which you can see on the screen, which is direct electric heating and air source heat pumps. The direct electric for both failed the AECB. This would have failed the AECB a few months later, but at that time, direct electric heating wasn't prohibited in the AECB standard. So I had quite a lot of conversations with Mark and Andy about whether this was allowable, and it was agreed that it would be. The hot water heat pump ducts air from the outside. The heat pump sits on top of the 200-litre cylinder and brings in the air from outside, where the heat pump does its thing and takes the heat out of the air, puts it into the water. So that's how that works. But those ducts have to be treated the same as MVHR ducts, so they're insulated with a vapor-tight insulation. And so in the end, to end of 2023-ish, all the buildings were certified to the AECB standard. And we've been back and we've looked at the energy performance of the buildings. So each column there is a building, and the columns, as opposed to the lines, represent the metered heat to the building. And by heat, that means the energy for the heating and the hot water. The split between the orange and the blue is an estimate of the hot water subtracted from the total heat. So that's just rough, but the total height of the line is correct. Just want to talk about this building. So this is one of the apartment blocks, and it's under-occupied because that's the block with the guest houses in it, which aren't currently occupied. And maybe there's not full occupation there. And those two as well, just of interest, because they're the ones using higher than expected amount of energy. So the predicted lines are the model, the PHPP model results. So other than those three buildings, it looks like all of them are performing pretty well compared to predicted. And then just looking at that, that's the hot water on that one. So the reason for that one is that a lot of these hot water heat pumps have been failing. And as far as I understand it, around 10 of them out of 50 odd have failed on the site already in the first 2 years. And some of each resident has been going back to Dimplex and saying, my heat pumps failed, and most recently they've come back and said sorry, beyond the warranty. So there's a discussion going on about that now. There's the AECB standard, so that line can be compared to the height of the blue part of the column. So we're miles under the AECB standard, so we're overperforming massively compared to the AECB standard. And that's the passive house. Somehow it's jolted out of place a little bit, but it should be on 15. So some of the buildings are performing quite close to passive house as well. That's heating demand, and of course direct electricity is heating demand with this design. And this is the energy use intensity. So that's predicted energy versus, is the total energy supplied to each house, and predicted versus modelled. And that's the UK net zero carbon building standard level. So you can see that these AECB buildings are getting pretty close to that standard or achieving it. I went back to site quite recently and had a chat with about 10 residents and got some feedback from them. And a lot of the things that I heard are things that we expect to hear and that people who stand in front of audiences like this say. So it's no drafts, no mold or condensation, it's quiet, it's fantastic, I'm thrilled with the comfort, the building heats up so quickly, the energy use is low. They're not very familiar with the energy use and costs yet because they haven't paid for it yet. And they don't use their radiators upstairs. So, but there was some other things that people were saying as well, which were a little bit more worrying. And when I heard them, I was thinking, right, I've got this presentation to do in a couple of weeks. What am I going to say? So, and of course, I am going to say what's happening, because that's the spirit of this. I don't just want to say this is an amazing scheme. It is an amazing scheme, and when you go there and you meet the residents, it is absolutely amazing. But there are some problems. So I've already talked to you about these failing domestic hot water heat pumps. That's a big deal. We're taking it up with Bournemouth Churches Housing Association, with CG Fry, and with the group as a whole, rather than just saying my heat pump's failed. It's saying, look, 10 of these have failed, what's going on? Because that's just totally unacceptable. People were complaining about cupboards full of plant, because that's part of the VE process, was that for those cupboards to be, they lost space basically when the insulation moved down. They were told by the second commissioner of the ventilation not to open the windows when the ventilation was on. And the housing group did a video and sent it to all the occupants saying they mustn't open the windows. So that's something I've now got to try and undo. And I was saying, no, you can. And I think what it's done, it's led to people turning the ventilation off so that they can open their windows. So there's a kind of culture of turning the ventilation off across the whole site. There was some talk of overheating as well. Well, I suspect that could be linked by being told not to open their windows. And there was some people talking about MVHR noise as well. So that's something we also want to revisit. So what did we learn? And a lot of what we learned and what I learned was reinforcing things we kind of already knew, but every time we do it, we learn it more. It gets reinforced. So the QA effort for AECB standard is similar to passive house. The performance gap appears to be eliminated in general, but we don't really know much about the occupancy of the buildings, so it might not be that, there's more to it than that. Off-site manufacture, some people kind of imagine that solved the airtightness problem. Well, it hasn't. And training and preparation and sequencing are absolutely critical, off-site manufacture or not. The timber framers are often blasé about airtightness, but they'll never take responsibility for it. That's my experience. They'll do everything they can to say that, oh, it's not, they can't, this bit of airtightness isn't them. Value engineering often has unintended consequences, this time pushing the ventilation into cupboards, which weren't there for storage, causing more convoluted duct routes. And then in detail building services, even on our projects which we're doing now, and we know this, the ventilation design's being done by the installer kind of last minute. And so there is a design, but actually all the acoustics and everything else hasn't been worked out in detail until the last minute. So we need to push that earlier. I'm going to need some persuasion to use those ADEL domestic hot water heat pumps again. And ventilation commissioning particularly is often very pressured because it's right at the end of the job. And there's pressure from everyone. There's pressure from the client, the contractor. Everybody wants this done fast. Nobody wants to hear about any problems. And so we need to make sure that the designs are better earlier so that that process is easier. But I didn't want to end on all the problems. I wanted to end by just showing you this photograph, and okay, it's probably stage, but it is a fantastic project. The people love it. The people have been engaged in lots of them in the process from beginning to end. There are people who couldn't afford housing there, and they've got these wonderful houses on this wonderful site with a beautiful community. So that's how I wanted to finish. Thank you.